All right. First of all, I want to ask from Calc 1, did you have any questions that you never did understand, especially for derivatives and antiderivatives? Did you ever have something that you always wanted to ask but were scared to ask because you sound like an idiot? Anybody have any questions like that? So if I asked y'all what the definition of a derivative is, all of you could tell us, right? I'm sorry, I didn't hear anything. That wasn't rhetorical. Okay, my class, you don't need to say anything because I know you know. If you don't, then you're a loser. But what about out of the other classes? If I asked you what the definition of a derivative is, what would you tell me? Huh? Yeah, you got the slope in there. That's true. Instantaneous slope. How do you get that? The change in x over y. Would you be surprised that there's a lot of calc students that go through calc 1 and calc 2 and don't know what the derivative is? Would you be surprised? Okay, I guarantee you there's somebody in here that don't know because they're saying, okay, so let's go through that. Just right quick, just as a review, because I'm going to go over a review, and if you don't like it, then just go home, okay? Um, I hope this thing works. If it doesn't, then we're just going to quit and go home. How about that? So we're not good people. All right, let's say that we have, ooh, this looks better than the other. Maybe it's better that it don't have a lot of bumps. It clears up the center. All right, let's say we've got a curve, and it looks something like that. And we have 2 points. We have a point there and a point there. And let's see, how do I do this? Did I? Hold on. There it is. And let's say, oh, this is the first time I've used this thing since since the 1600s. Why isn't it working? What? I know, I did. There. Let's go up. Straight line. I want a straight line. There we go. And I want it to wait a minute. I know why it's not working. I don't have anything on my board up here. That's not supposed to be happening. Now that pretty much sucks, doesn't it? Y'all sound. What? You're working on way. You're working on your way up here to draw for me. You don't want to do that? Oh, I don't want to do that. All right, that line right there goes through 2 points. It's supposed to be moving, but there we go. Move it 3 inches out of the way. There we go. All right, there's your line. And we all know from algebra that the slope is equal to delta y over delta x. And that's what basically you're finding. But a lot of people cannot make the transition between the algebra and the calculus because of the limit. And the limit theory is, and my Calc 1 students will tell you that I go through that over and over and over. We're going to skip it in here, but the limit, you take the algebra plus the limit theory. And the limit theory is basically take a half step toward the wall, and will you ever reach the wall? Now, if you had me before, you'll know what I'm talking about. But if you didn't, you need to go back to the videos from last semester and pull up 140, and you'll see. In other words, if I take a half step toward that wall, and then each step I take half of the previous step, or I take a full step toward that wall, and I take half of a 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 step, will I ever reach the wall? No. So you put these two entities together, add them together, and you have the calculus. Okay? What does that mean? Well, let's say take this for instance. We know that this point right here is, we call it x again, LS. Then we know that this is y. Yeah, when you're redneck, it's y, but we can't do redneck in calculus because we got to stir pinky up, and we have to call it what? F of x. Okay? And then this guy is x plus c, x plus d, x plus h, whatever you want to call it, because you can't say that this is x and this is x. You can't say that. You can say that this is x and this is g, or you can say this is x and this is that and this and that and the other. So what we're going to do is we're going to call this distance right here h. So therefore, this point is what? X plus a. Now my Calc 1 students should be yawning right about now, and hopefully all of y'all are yawning right now because we're doing this stuff that you should know. But I guarantee you out of 25 people, there's probably 4 or 5 of y'all that still don't understand what you're doing here. So I'm going to try to help those girls. So if this is x, and this is f of x, if this is x plus h, then what is this right here? F of x plus h. Okay, everybody with me? So, that's this guy right here. We just did this. Alright? We're working on this right now. We got to do one more thing, and that is find the slope. Whatever. Find the slope. Now, some of you may not like delta y over delta x. Too chemistry heavy. So you go, okay, well that's derivative, or not derivative, the slope is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Does that look pretty algebra enough for some of y'all? Okay? So let's go ahead and put our points up here because we've got everything expanded out. So I'm going to take my handy dandy green marker. Okay, I'm supposed to be able to hit this thing. Why isn't it doing it? Last semester, one time you'd come in and the eraser would work. The next time it come in, it wouldn't work. And so far, I've got one line up here. I've got a purple line up here, magenta, sorry. I've got a magenta line on my screen and nothing else. So, something's wrong with this. Alright, so this point right here, if I wanted to put a coordinate on it, x, comma, f of x. Everybody with me? And this one is f of, let's call it x plus h, comma, f of x plus h. Everybody with me? X, y, x, y. Now I want everybody in here to plug all that in to this right here. Plug it in. And a lot of people say, well, I don't know what to plug in. Well, we play the gradient. Left to right, and this is fundamental length, my lemma. Move left to right. So this is x sub 1. This is y sub 1. This is x sub 2. This is y sub 2. Plug and play. a full board up here, but nothing up here. I hope y'all getting this on the, I hope it's recording. I hope not, because then y'all gonna get one line. So, here we go. And of course, I always use print screen when I plug into it, because I need it. And what is y2? F of x plus h. And what's y1? F of x. And what's x2? And what's x1? And up here we get f of x plus h minus f of x. Over what? H. Somebody tell me what this is. Okay, that's 2553. That's difference equation, which is your prehistoric derivative. So your difference equation. Now, tell me what the difference equation actually is. You just figured it. What is it? What? I guarantee you somebody in here is going, oh. Okay? The difference equation is actually, like you said, what? Well, what's the difference between that? Well, we're still in algebra. We haven't even touched calculus yet. This is the algebra. We just did this right here. Okay? Now, a while ago I asked y'all what the definition was, and you said instantaneous. And that's where you use calculus with this guy. Alright? Now I can't do it because I don't have a good sketch pad, but you apply the limit theory to your algebra that you learned, and you bring this guy. That's not supposed to be long. That's not supposed to be a whole Okay. If I was to take this guy and apply the limit theory, take half of the step, let's say that this is 4 feet. And half of this would be what? Half of the previous step would be 2 feet. Half of that would be 1 foot. Half of that would be half a foot. And that line, which put this thing to work, half a step, 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 half a step. And basically, you get down to, and what I used to say, a hair's width, right there, between those two lines. And when that happens, the secant line has just turned into what? The tangent line. Miss Anthony, I'm impressed. You must have had a pretty good dadgum California teacher. Let's see. Since I don't have, I speak line. What? Whatever. Now I got to do this up here because I can't see it on the monitor. And now your magenta line has just turned into the tangent line. Now, what does that? Well, taking half a step, you can say taking half a step, half a step, half a step. So how are you going to say that here? Say, take half a step, half a step, half a step. Well, you do that by using the limit. And which one of these guys, I wish I could change colors, but I can't. Which one of these guys is doing the actual changing? X. But you can't say x plus h is converging onto x. You can't say that. So what you say is h is going to what? H is going to 0. So, I'm going to have to go to the next page. We're going to have to go up here. Just put pages. Oh, that's even better. I have a blank page up here. What do we have up there? A full page. Page 6. Yeah. Look at all them pages. Let me try this. I'm going to try something else. See, that's how I know what's wrong. That right there. Oh, I know what's happening. That is, I don't need this. Because I'm using this. Active Inspire. You don't even need the software for the projector. Watch. There we go. Uh-oh. It just disappeared. Now I don't know where it is. Okay, well, we'll just do the best we can. Let's see what happens when I do this. So, does that spin up there the whole time? Okay, well, I don't know where it's this right here. It's not supposed to do. Somehow, somebody turned that whiteboard on, and that's why. Oh, that's not on. I don't know, people. I really don't know. I can't even erase it. See? Where's the trash can? You going back out? Why? This is Zoom. Okay, Brian, how you going to use it? This is in, I don't know where this is. There's what? Oh, yeah, sure. Let's just erase it. I can't see anything up here. There's the eraser, Mr. Ryder. What do you want me to do with it? No, I don't. You're going to fail anyway. No, I'm just kidding. Hold on a minute. Let me figure it out because I can't get rid of this. I can't. Okay. I know I've got engineers in here. Y'all should be able to fix this. Because then I would lose the recording of what I've done so far. I know. I might as well just quit, shouldn't I? Let's see if I can do this. Desktop, and I will take the eraser here. See, that's what the problem is. The problem is it's not there is something running that's not this and it's not Active Inspire. I don't know what's running. I know that, and that is this right here, which I keep turning on and off. That's this. I think it is, or whatever that little thing is down there. I have to hit and I'm trying to get it to turn off, and I can't get it to turn off. That's that. just restart the whole computer, and then I'll have to spend another 15 minutes pulling everything up. I'm sorry, people. I haven't had to deal with. I don't think I've had to deal with this before. I can't get rid of that. Oh, I know what you meant by control alternate delete. It's not on there. Active inspire needs interactive. Somehow, somebody has turned something on with this guy. Let's try that. Good idea. Yeah, he'll come back on eventually. Sorry about that. I've never had to deal with whiteboard being on. Evidently somebody had it on before class started. The thing blew up. It's on, isn't it? See, this is where training would come in real nice. Be very handy. Never did. Well, at least we got rid of the screen. I meant the previous work. Yeah, I'm talking about the stuff that was on the screen. No, the computer. I didn't restart the computer. I restarted the projector. I do, and that's fine. But I think it was the problem was this was on. So you have the computer, you have the computer's the software for that thing, and then you have the software without the computer. And the software without the computer was on. So we should be able to. Yep. Yeah. So it's getting all whatever. Yeah. Yeah. Because this software does not have video capture on it, so I can't capture what I'm doing. This software does. So let's see what happens now. We still got this right here, and we have this right here, and this right here, and this guy is coming down, 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 getting right there, and we have a single line there. And what the quotient, difference quotient does, alphabet, n, I know what's happening. This does not work. This. No. No. Say again. Maybe. I'm getting a little bit confused, so you just have to hold on a minute. Now let me try this. See, I have nothing on my computer right now. Do y'all see my mouse? Okay, there it is. I have an eraser. Thank you, Mr. Ryder. Mr. Ryder, nothing gets by Mr. Ryder. Okay, we're just gonna keep on going. M as the limit of h, or we could just do that. Limit of h approaches 0 of f of x plus h minus f of x over h. And as this guy goes to 0, as h goes to 0, because the difference x and x plus h, as h goes to 0, you get basically this right here. And that turns into that, and this is what you call your prehistoric derivative. In other words, it's the derivative that you get instead of using the derivative law. In other words, let's say that you have, there's something I'm not getting, so y'all just gonna have to let me work through it, and I'll get it. Let's change this to whiteboard. See, it's not. And let's change the other one to a whiteboard and see what that does. Yeah, something is still not right because it's neither one. It has to be. The projector is doing it, and I don't know how to. I know. See, that should do it. It's not. Whiteboard is changing it from whiteboard. See, this is whiteboard and this is transparent. So I can still write. So see, that should be. Not clear screen yet. See, it should be clearing, but it's not. So I'm just going to have to work with it. I don't know. I don't understand what's happening. I saw it in this classroom all day yesterday and didn't have this problem at all. So I don't know. So anyway, if I want to take f of x is equal to 2x, or 2x squared, and I wanted to find the derivative of that. Well, let's see what that is. 2x squared means that you're going to have a parabola at 0, 0. Instead of it being wide like a regular parabola, it's going to be what? It's going to be skinny. Of course, y'all should know that from your college algebra. And we want to find the slope, the equation of slope at this point, and that is, let's say 2, and 2 would be what, 8? 2 and 8? 2 is something like that. So we take our handy dandy. See, another thing that I know is not working is the colors. Colors are not working. I know it is. There it goes. That's it. Let me go to transparent. Maybe that'll fix it. No, that's the whiteboard. Yeah, but it's not. Let's show back up as a transparent. There's the transparent. Yeah, that'll work. See, that's what I've been saying the whole time. This thing is on, and I can't turn it off. Well, I can use it. It's just that I don't know why this is on. I don't know why I can't turn it off. Yes, sir. Let me be in charge for a while. What? Yeah. Yeah. And we did that. It did. You marked the word the other. Okay, as long as it's recording, I don't care. Okay, thank you, sir. try this. All right, so let's let this is 2x. And that gives us this. And let's say we want to know what 2 and 8. We want to know what the slope of that line is right there at 2, 8. Well, the old way, before we started using the rules of calculus, is to take this and plug it into what? The difference equation. Limit as x approaches 0, I'm sorry, 8, of 2x squared, which will be, and the first thing you do is you rewrite this with a big circle parentheses minus f of x, which is 2x squared, over 8. And what do you plug in here? Good God. X plus 8. You plug that in. And then what do you do? Well, you're back in algebra 1 now. Or algebra 2. This is all algebra. All the calculus you use is right here. So, limit and whatever, versus 0 is equal to 2x squared plus 4, help me out, xh plus 2h squared minus 2x squared over 8. And something's good to go out. All the x terms should be what? Or x squared times 10. Something. And then you're left with 4xh plus 2h squared over 8. Limit, blah, 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 0, blah, blah, blah. And then take out the 8. Goes out, you're left with 4x plus what? 2h? 4x plus 2h. And what happens when you apply the limit to that? You get what? You get 4x. What do you do with 4x? Well, depends on what question you ask. If the question is just asking for the equation of the slope, then 4x is your answer. If the equation is asking for the slope to the point, then you got to plug in what? You got to plug in what? 2? And solve it for, because what you got to plug in. No, it would actually be 4x. That's the answer to the equation. Yes. Borderline is the tangent line. So the equation of this line is what? 4x. So y is equal to 4. Oh, sorry. Both of those is equal to 4x. And that is the equation for that blue line, the black line there. Now, another way to do it is forget all the prehistoric stuff and just use your power rule. 2 times 2 is what? And 2 minus 1 is 1 equals 4x. And what is back here? Now that's a little bit of review on derivatives. And hopefully everybody in here now knows what a derivative does. Okay? Despite our technical difficulties. Thanks to Mr. Gialdi. Now what is the integral? Integration is the kind of undoing. Well, let me do this. Derivatives give us the slope, the equation, the slope of the tangent line. Everybody with me? And what does the antiderivative give us? Area under what? Gives us the area under what? Basically gives us area under a curve. So if I was to go through and ask everybody in here, explain to me the antiderivative or the integral,
then hopefully 100% of you would be able to show me how to get the area under a curve, right? Yeah, 2 nods and that's right. So it's 3 out of 25. What about the other 22 people? Probably 15 of y'all would be able to. There's still those 5 that, so we'll go through that and then we'll move on to some of our rules. And then we'll move on to area under a curve and all that good stuff. All right, so our area between two curves. So here's our handy dandy graph, and we have a curve right there, and we want to know the area under it. Now, of course, this would be real nice if I had my GeoSketch, because then I could put this in and show you without having to screw it up with my drawings. So, and 9 times out of 10, to get the area of this guy, you would take your handy green marker, and you would do that, and then you would break this up into maybe something like this, and then maybe something like this. And you add those 3 areas up. And that would be your algebraic way of doing it. But we're not in algebra, so we're not going to do that. But what you could do is take those rectangles that you drew, that rectangle right here, and maybe do something like this. This is where the DVD really helps. There we go. All of them just beside. Each one of them has the same width. And then you could go through and, now all I'm saying is that this right here would be what? This would be your oval. Little area right here, or you could do this little, it depends on which way you like to look at it. Okay? Some people like to look at it as oval, some people like to look at it as a cone. So I don't care which way you look at it, it's still cone. But the area cannot be negative. Now the whole point of me showing you this is there, and then there, and here. Now, finding the area under curve. Now, a lot of you say, well, when are you ever going to find the area under a curve? A lot of people find the area under a curve, especially civil engineers, surveyors, and architects. Why? Well, when you're cutting off a piece of property for a highway, you think that highway is going to be straight 100% of the time? No, you're going to have horizontal curves. Horizontal curve is what goes around the house. It goes around the apartment. It goes around, that's the horizontal curve. Vertical curve is between two acres. So that's here. All right, you're going to have horizontal curves. And when you have horizontal curves, you've got to figure the area, especially when you're working for right-of-way. So let's say this is a curve going through my property, and my house is right here. And when you're doing this curve, you've got to figure the property that is going to be affected by this curve and how it's affected. Now, you could do this and say, well, we're going to buy your property, and we figured it using the rectangle, we figured it at 28. You as a property owner would say what? Huh? We're going to give you money for 20 acres. What would you say? We use the rectangular method here, and we're going to give you 20 acres. We're going to buy 20 acres from you. Well, you don't know if it's, we don't know, because it depends on which way you look. All right? The 20 acres could include these guys, the blank ones. And that would be what? Over. And then this would be under. So, in other words, is it accurate? No. And a lot of you say, well, it's not that much. Well, what if you had 2,000 acres? What if that block was 2,000 acres? Each one of those little rectangles become what? a little bit bigger. Those triangles become a little bit bigger. Are you talking money now? Yeah. It's just like the Powerball. $1.4 billion. Uh, the first Powerball, probably the first 3 days after the last Powerball wasn't $10 million. Is $10 million the same as 1.4 billion? No, it's not. So 2,000 acres, 220 acres, these little triangles don't matter really. But at 2,000 acres or 20,000 acres, you're talking a lot of money, especially to the South Carolina Department of Transportation, which would be buying up that land for the curve. Okay? So, what do? Well, you take the area under area that you learned in algebra, and you put it with the limit theory, except this time you're finding the length times the width of this curve, but the x is going to what? To 0. Now, what does that mean? That means that this, instead of having a big gap right here, is going down here. Any CAD people in here? I'd ask this out of my Calc 1 class, because this is the best. All right, CAD. Now, what's the latest CAD that's come out? Before it changed, 13 was the last one, and it changed to CAD Lite or something. I don't know. Yeah. Okay. Well, the last version of CAD that come out, and if you're dealing with CAD, I'm talking about hatching. You know what a hatch is? When you fill in something like a box and you fill it in with color. All right, if you zoom window on that like 50,000 times, basically you're going to see this right here. You're going to see little lines that are what? That are that close together. And they're so close together you have to zoom in 50 times to actually see that they're that far apart. See what I'm saying? So think of, and when you actually see something hatch in CAD, and a lot of you think, what is CAD? I'm showing you how to visualize this. Let's say you've got this, and this is a drawing in CAD. If you was to actually hatch it and color it with blue, what the computer actually does, you think the computer just goes in there and throws a big splotch of paint in there. No, it doesn't. Look at that. Now, is it this nasty? And no, just a straight line about a hair width apart. And if you blow up, I wish I could, you blow up the hatch, about, well, actually it's about 4 or 5 times. If you blow it up, this little area right here, you blow it up, you see that there's nothing but what? A little straight line, side by side. But when you blow out, when you do zoom window or zoom out, all you see is what? Color. And that's what this is. You're basically taking this area under the curve and you're turning these big rectangles that are 50 feet wide and 200 feet long into 0.01 rectangles with a width of 0.01, which is 100th, okay, of an inch of a foot. And the length of it doesn't matter because the length of it is the actual what? The curve. Okay? And then you multiply it by however many, what is it, 0 to 20 feet, 20 miles, or whatever the case is. So an antiderivative from 0 to 20 of, I'm just going to make that simple, 2x to the third minus 1 dx. What you're doing, let's say that this is represented by that line, which is not. So we did that this way, the 2x to the third, but we're just filling it in. And you're going from 0 to 20. You're multiplying each one of these by 20, okay, of whatever the antiderivative is, which is those little hairs. Called hairs. That's what they turn out to be. The little rectangles off the width of the hair. Now, there is no prehistoric antiderivative. There's this rule. And that is,
okay, to 3. What do you do? What do you do with this? You got to remember, because some of you get in the derivative mode, and then when you get to antiderivative, you go, okay, what do I do first? What do? Remember, you have to do what to the exponent? Add 1. And if you add 1 to the exponent, what do you got to do to the denominator? You got to take that whole thing and put it on the bottom. Okay, so in this case, and let's say you are between Calc 1 and Calc 2, you're going through this review, and you're saying, I'm losing. I know how to do the derivative, but can you rewrite everything like it is? Okay. Always revert back to your root. 2x to the third minus 1x to the what? 0. Always go back to the root. And now, then your tangent as your that marker. I'm going to add 1 right here. I'm going to add 3x in here. I'm going to add 1 here. I'm going to add 0 plus 1 here. Y'all forgetting a lot over the break. That's what this section is for, is just to bring everybody up to speed. I'm sure you all pick it up. And that's going to give us 2x to the 4th over 4. Okay, whatever. Minus x to the first over 1, which is x to the first. And then it comes out to 1/2 x to the 4th. So 1/2 x to the 4th is a minus x. Evaluated at 0 and 1. 20. And that could be 20 miles, it could be whatever. We're not worried about that. So this, I don't like this, I'm going to change it. So that'll be x to the 4th over 2 minus x evaluated at 0 and 20. I'll do 0 for you. And then y'all do 20. 20 to the 4th over 2 minus 20, huh? Whatever y'all say. Y'all check it out. So divide that by 43,560. And that comes out to what? If you do it over here. What does it come out to? 0.0 something. What is it? Okay, 16,000 is not right. Okay, so y'all set me up. Appreciate it. Who is that set me up for 16,000? 43,560. How many pages? Anyway, what's 20? What do you come up with? 160,000. Now we've gone to 160,000. I don't trust any of y'all, okay? There's the answer right there. All right, and that's the area under that curve. Question? I'm sorry, what? Well, yeah, but what happened? That's why I said I'm going to do the 0 for y'all. 0 plus 0 is what? Okay? Miss Anthony, what do you say? Miss Anthony, do you say that you remembering all this stuff from the break now? Hold on a minute. I'm going to pull a couple out of the notebook so we can do some. Let's find the area. Let's do negative x squared plus 4x. Let me get a new page here. Negative x squared plus 4x plus 1. Negative x squared plus 4x plus plus 1. Now, before you do it, I want you to actually draw it. Why? Why is it so important to just draw it? So we're going to take up all your time. Why?
No, there aren't too many War and Peacers in here. Most of y'all are visual learners that would be in engineering. Okay? It's always best when you start a problem to actually what? See it. You ever met one of these people that go, I need you to find out where I went wrong with this problem. First thing they say, well, let me do the problem so I can see it. You ever heard that? That's why most of us in here are visual learners. You don't learn by reading 15,000 pages. You learn by watching a video or looking at a picture. Okay? So it kind of helps to see what you're doing. And we're going from, let's go from 0 to 10. This is what's applied. Negative x squared plus 4x plus 1 dx. Oh God, you got three things. Okay, what are we doing with three things? It's going to hurt to mess with the equation if I'm doing this way. The best thing to do when you get to a rough spot is what? Good job. I taught my Calc 1 students well. Quit. Throw your pencil down and make that pop on the notebook paper. Y'all know how to do that, don't you? There you go. When you really get mad, it makes a real loud pop. You work at BMW. You get to drive around a BMW. How does that work? I always wondered how that works. Driving around a BMW. How does that work? Oh, well, that's pretty good. It is, because you don't have anything at the end. Kind of like living in an apartment. One of my first fights with my ex-wife was over an apartment. And I said, honey, no apartment. You move in a dadgum trailer or we get a dadgum small house. I said, I'll have something at the end of 10, 15 years or whatever. And I did. Sold the trailer. Made about $10,000 off of it. I did pretty good on it. Those trailers are not easy to sell. I think the trailers are like 12 years. I'm sorry, mobile home. Not a mobile home, it's tires taken out from under it. I'm just looking. I'm looking to see how many people are working, how many people need to be here, and how many people are fluid. Not fluid, but need copy. What do you do with a multi-step, you break it what? Break it up. You can break it up, or you can do it in your head, just to break up every single one. I don't care how you do it, okay? But, that would be negative what? Negative x cubed over what? 3 plus 4x squared over 2 plus, that's it, that's 0. So that'd be x to the first over 1. Evaluated at 0 and 10. Now I'm going to reduce it down a little bit more. Negative x cubed over 3 plus, that'd be what, 1 half x squared over, 2x squared, 2x squared plus x. Evaluated 0 and 10. I'll do the 0 for you. I did in my head. And the other is negative, what is that, 1,000? 3 plus, that'd be the 200, which would be 600 over 3 plus 10. What's 10 times 10? And what's 100 times 2? 200 over 1. We can't add 200 over 1 plus something over 3. You've got to have a common point. Is that not a common denominator? Maybe y'all was using your calculator. I'm sorry. Didn't have a calculator out right now. Okay? And that's going to be 10 over 1, which is what? A while ago, I was walking by, and I saw this, and then I just saw the principal just sitting there like this. I was walking, and I said, it looks like this, negative 1,000 over 3 plus, and the principal was just sitting there and said, and it happened. So involves some fraction. Right? Now you were in Calc 2 last semester, or Calc 1 last semester, you may have some thought, well, you got to remember to use the common denominator. Negative 1,000 plus 600 is negative what? Negative 400 plus 30 is what? Negative 370 over 3. Now, why am I doing this? Why am I taking my eraser and erasing the negative? Because you can't have it. But what it's telling you is that, well, when you draw you know this is opening this way. It's opening downward, that's why. So, and that comes out to be 123. 123. So again, told you, handy dandy, talking about a vertical y-intercept is 1. And it's negative for the regular parabola. Do something like this. And from 0 to 10, I don't know where that is. You just have to do it. Now you can do that with your graphing calculator if you want to. Alright? Now, I'm going to throw another one at you. Again, it's Calc 1. But I'm going to throw a little bit of a curve in for you. See if you can figure out the easy way to do it. There's 2 ways to do it. There's 2 ways to do this problem. But first you need to draw it so you can actually see the 2 different ways. If you don't see it, just by looking at it. Half the class is going, oh, that's a parabola, and I can do it this way or I can do it this way. Just by looking at it. And half the class is going, well, I better draw that out just to see what he's talking about. The y-intercept of 2. Now, what am I wanting you to see on this problem? That's not rhetorical. I'm actually asking y'all for interaction. And what is that called? Symmetrical. In other words, you can do double the work or you can do half the work and what? Double. And again, that's something that I'm just making sure that everybody realizes. I'm not trying to insult anybody's intelligence, but you've got a parabola that is half, that means it's wider, and you've got a vertical shift of what? 2, so that means that the vertex is going to be, let's just draw it out. You'll need 1 half x squared plus 0x plus 1 is equal to 2 plus 1 plus a negative. And you factor out a 1 half, so that's going to be x squared plus 0x plus 1 equals negative 2 plus 1 half blank. And then half 0, 0, 0 plus 0 is 0, so that comes out to be 1 half times x plus 0 squared equals negative 2. So we've got a vertex of 0, negative 2. That's what I thought. So that means that 0, positive 2. So that means 0, 2 is right here. Or you could just say right intercept 0 plus 2. You could do either one. And there's no x-intercept because it's what? Huh? Because it's a negative. That's right, Paul. And we're wanting it from negative 3 to positive 3. And these guys are what? Symmetrical. So we just say no exclusion. Now I'm not going to do too far. I'm not going to do double the work. So that's going to be 2 times the antiderivative, so 0 is 3, of 1 half x squared plus 2 dx. That's going to be 2. And I'm just going to go ahead and write this in brackets. And that's going to be 1 half is x squared over what? 3? X cubed over 3 into what? Plus, that's x to the 0, so that's going to be 2x to the 1 over 1, evaluated at 0 and 3. And this is going to come out to be x cubed over what? 6? 2 times x cubed over 6 plus what? 12x over 6? Evaluated at 0 and 3. And 0, I'll do that one for you. Comes out to be 0. 3, plug that in, you get 2. That's going to be 3 to the 3rd power over 6 plus 12 times 3 over 6. That's going to be 27 plus what? 36? I have no idea. 2, 27 plus 36, we'll get to it in a second, over 6. And 27 plus 36 is going to be what? 63. Y'all help me out. Which is 10. 10 times 2 is 20. Now, if you did it the other way, you should get the same thing. Okay? All right. What do you think? Refreshing you a little bit? You feel good about it? How about the people that wasn't in my Calc 1 class? How you feel? Let me know. Say something. Huh? Good. That's what I want to hear, because I want to hear from the people that don't know me, because I want to know if you feel like, you know, and this is a review, so don't worry. We're going to get to the stuff that's going to give you fits. We'll get there. Yes, sir. Okay, yeah, I got the squiggly line right here. That's approximate. Oh, yeah, you're trying to make me look bad. That's what it is. No, you're fine. It should be around 20, 21, somewhere around there. I didn't do I did 60 divided by 6 in my head. That's, I don't care if you get 20 or 21. All I care about really is to hear back. That's what I care about. Now, if you get 72, then something's wrong. Okay? All righty. How about anybody else? Let me ask you something. I'm just wanting to know this. How many of you feel better about the derivative and the antiderivative now? Good. What are you raising your hand for? You're supposed to learn it last semester. Oh, I'm sorry. Okay, now, this is what y'all need to be doing. Except the dishes are all here. Y'all need to be working on 3 things. And you can go ahead and start packing up. You need to be working on getting on the website for the 6 or 7 people that are losing, that haven't done it yet. You need to get on that. And did y'all see on there the review for the derivatives and the antiderivatives? That's what y'all need to be working on. I don't know if this thing will send me questions. They said it will. I'll have to check into it. But for some of you, if you didn't ask my instructor, let me know if you did that. Hit the ask my instructor or send to my instructor, and then we'll do it in class. But I got to look at that and see if it's turned on, okay? Continue to get your book. You don't need to have a book. You can have an open. In fact, some of you, if y'all want a calculus book, I think I've got 3 or 4 in my office, okay? You're welcome to come by and get them, because I've got books sticking out of my ears, okay? Any questions for me? Then Wednesday, or when do y'all come back? Tuesday? Tuesday, we'll be continuing. We'll probably get into areas between curves, and then we'll move into the volumes and the disk and the shells. Hold on a second, I got to call the roll. And we'll move into that probably Tuesday. I'm going to spend about a week, maybe a week and a half on the review, okay? If that's okay with y'all. I mean, we can move right on into tanks if y'all want to, but. Yeah, but we didn't do work. We just did the drainage. We didn't do the work. How much work it takes. Yeah, that's really gonna that's really, most of you are gonna fail after that, yeah. What? Well, then that means you don't have a prayer in here. You might as well just go ahead and drop. Okay, Anthony's here, Blair's here, Blankenship is here, Bolt, Brooks is here, Brown, Brialdi is here, Hammer. There's no forgetting that name. Hammer. Khalil. Klutz is here. Loftus, Pickens, Rochester, Ryder is here. Sanders, Savasta is here. Schaller is here. Silver is here. Steedley, Street, Swanson is here. Treya, is it Trela? Trela, okay. I see so many L's nowadays, and it's supposed to be Treya, because everything is, got a, whatever, the Y thing, okay? Wagler, Waldner, and Warson. Man, everybody's here? Wow. All right, y'all have a good day. See y'all Tuesday.